So welcome back, everybody. We will start our next talk with Felix Frank, and he will talk about what's wrong about Puppet. Enjoy.
Thanks. Hi. I'm Felix, and yeah, we are talking about Puppet, and I think there's nothing wrong with Puppet per se, but yeah, we get to that. So a bit about me. I'm an operations person. I have been an operations person for quite a while. My first assignment was at a physics institute, which is actually a CF Engine shop. That was interesting, although I didn't get to do much with CF Engine in my time there. And then I spent 6 years at a managed hosting provider and did all the things with Puppet. That was pretty neat. And just a few months ago, I switched to yet another managed services provider, the Unbelievable Machine Company. We do managed hosting, managed services, but there's a focus on big data, and we do some things beyond that. I'll get a bit more into that later. And well, Puppet was nice enough to rebrand right in this time frame, so this slide is nicely balanced. I do have a Twitter, I do have a blog. Check those out if that's things that interest you. Okay, with that out of the way, we already tested that everything is readable. Can everybody understand what I'm saying? Can you hear me breathing? That's been an issue in this venue, so guess this works. All right, so software, right? I mean, does it even work most of the time, or is it more like, oh yeah, I have the software, and this time around it even did what I wanted it to do, and I didn't spend days frickling with it. But truth is, most software will behave erratically, and Puppet is a fairly complex piece of software, and it can and will fail in very exciting ways. Matter of fact, there's so many ways in which Puppet can do things wrong for you that I cannot possibly cover all the bases. So I'm going to focus on a couple of things that typically can go wrong and trip you up, and see if I can give you some help towards getting a grip on these scenarios. So one thing that we see in everyday operation is that you configure Puppet and you're pretty sure that it will now do the thing that you want it to do, but somehow configuration isn't quite what you expected. Some component, be it the master, be it the agent, just won't like consume these new files that you have deployed and you expect to be read and used. And that can be pretty interesting and frustrating, and I'll just show you some ways that I use to get a handle on those cases. Of course, it's always fun when your manifest plainly won't compile or won't run and Puppet just won't work. I mean, that's pretty much something that can happen any other day, but there's some ways to navigate those as well, and I'd like to show those. And finally, sometimes things do compile and they will run, but they won't do what you want to do. My favorite is plainly nothing happens. So, yay, I added this new file resource to my manifest, or this exec should now fire. Nothing. So, what do? Let's find out. Also, just yesterday I found this relevant book, which is really interesting, and which encapsulates pretty well the state of affairs, which is sometimes Puppet tells you that something went wrong, but it's so opaque and so nondescript that it's pretty much impossible to glean what's going on. Thanks to Craig Dunn, by the way, for this one. Okay, so our first scenario is Puppet behaving some way, and you want it to behave another way, but nada. So there's two tools that I bring into play for this. So one I'm designating the hammer, which is not very subtle approach, but it's a very using S-trace, you can analyze all kind of things. You can also use it to watch your other pieces of software, not only Puppet. So it's something that I like using, not if all else fails, but when I'm too lazy to get more into depth. And usually I'm pretty lazy. If you want to be a little more subtle about it, Puppet brings some tools of its own. Being the config print suite, and we'll see those in action as well. So it's live demo time. Focus. Okay, this will be interesting because I cannot see what I'm typing here, so all errors are my own. Simple example. You're running Puppet and you want to find out what puppet.conf file is actually being read, because there could be more than one puppet.conf file in your system for whatever reason. Like you are running Puppet in different contexts. Different groups have different Puppet agent environments. So the S-trace approach is simple enough. We wrap our usual call with S-trace. Let's do a simple apply. Oops, off to a good start. All right, so I like using Puppet apply for simple testing because I can just pass manifest code right on the CLI. That's probably something that folks who use master and agent don't do often, and the folks who use masterless Puppet do all the time. But it's pretty neat. It's pretty helpful. And so this is just a call to do a simple statement on the console, and S-trace of its own will dump a whole lot of information on us about all the system calls that are being done. It's a good idea to limit those to the operations that are pertinent to the file system. And that's still quite a lot. So what you want to do is, of course, you grab that. But since S-trace helpfully puts all the information on the standard error, you want to redirect that to standard out before you pipe that anywhere. So now that's done. Let's look for the puppet.conf. What? Huh. That's not a lot going on. Notice, thank you. What the? Okay. You know, I shouldn't have prepared this live demo on a Linux system rather than a Mac. So, bummer. I think S-trace is not an option at the moment. I won't bore you with me reading lots of man pages on finding out how S-trace works on a Mac, because, oh man. Seriously though, okay, you know what? Let's just look at my canned slides about that. So I would have done pretty much just that. And on a Linux system, this is what happens. You get some lines of output. In this case, really not much, just that a puppet.conf file was found and was opened. And in this case, because I'm not running as a root, it's being pulled from my home directory. And there's a .puppet labs tree there, and this is Puppet 4 running. So things are in .puppet labs. If you're running Puppet 3, you'll find things in .puppet. Or if you're root, it's an etc Puppet, and for Puppet 4, it's etc Puppet labs. Okay. Now, I think looking for what PuppetConf is being used is a rather quaint example. Something more interesting is where the specific provider loaded. But because in some cases, your system can become a little unwieldy with the Ruby code floating around and can be hard to discern what Ruby code is loaded. As a matter of fact, Ruby will go all over the place looking for stuff. So if you do this, you get a wall of text, and it all says things like, oh, I looked in, hey, I see you've got the CF property list gem, so let's see if there are Puppet providers in there. Oh, there are none. Okay, I'm gonna keep looking. And so on and so forth. And if you do some Ruby development type stuff, you'll have lots of gems on your system. So that's a lot of lookups. But if you wade through all that, you will finally find that, yay, it found the Puppet gem, and there's providers in there. And yes, it loaded the app provider. Fun fact, just yesterday, I had a case where one of our agents behaved weirdly and couldn't apply a resource from that we added a file line resource from standard lib, right? And turned out one of the agents had a local installation of the standard lib module. So at some point, someone had done a Puppet module install of standard lib, but that was pretty old. And so the agent on that box would load the wrong file line type, and it wouldn't work. Didn't support all the parameters, and yeah, hijinks ensue. So that's pretty dangerous, and that's something that you can very well trace using this method. And matter of fact, I did. Okay, so back to PuppetConf. I told you we don't need to use strace for everything. And as a matter of fact, let's go back to demo mode. So let's call it the real way to find the PuppetConf is to use this neat tool. You can print all the configuration values from Puppet, and the location of the PuppetConf is yet another customizable value. So what I like doing when I don't know what an option is called, I will just print all configuration and grep for whatever I'm looking for. So let's see about PuppetConf. Okay, so there's like two matches. One is the config file name, which is PuppetConf. So I can change that to like chef.conf. That would be confusing, but what happens is this is used to build the full path to the PuppetConf that is used. So the value that is actually of interest here is the configuration, which is a great example. Well done. So what you can do instead is you tell the tool, just give me the value of config, so that I can tell where PuppetConf is being looked up, which just gives us this without the key value notation. So this is something that you can then use in your shell scripts, right? Kind of like this, and yay, now we know where PuppetConf is. Again, that is not the most powerful example, but you can put it to good use if you want to find out more information about what Puppet does, where it looks for stuff. Also, we'll get back to that in a later demo. All right. One thing that's important is to take note of in which section of the configuration you're moving about, right? You can configure the agent differently from the master. This is something that is usually not used extensively, but for some distinct values, it's pretty important to make sure that master and agent use the correct terms. So usually you want to pass the section option and can say like if I run Puppet as the agent, what is the Puppet conf? And if I run as master instead, what is that? Let's do something useful for fun. So let's see what cert name is in use. So someone configured the master to use localhost for the certificate CN. That's pretty crazy, right? But for the agent, that's even less useful. So that's actually my FQDN here. And so this is pretty basic. I could just look this up in puppet.conf and I get a pretty clear view of what's different between agent and master, but there are some, one of the other configuration value has different defaults for agent and master. And usually it's not an issue, but you don't want to be caught by this and at a bad moment don't take note of which section you're looking into with your Puppet config print call and work on wrong assumptions, because that can send you into the kind of debugging rabbit holes that you don't want to find yourself in. But then doing this dash section is pretty clunky to me. What I use instead all the time is this notation. So I'll just call whatever tool I want to invoke, like Puppet Agent. Puppet Agent is something that most of you probably type a lot throughout the course of a day, and then at the dash config print option. So this way you get configuration values only for the agent, and you can use it with master, you can use it with apply. And Puppet apply is supported by the section parameter, but you have to supply the user section, which is not very intuitive to me, and you can use it with all the other subcommands that are there as well. So yay for the config print alternative. Are there any questions so far? Please. Whether it's possible to get the parameters that are set on the command line? Oh, if you're configuring through the foreman, well, I'm not really sure. So I'm not really familiar with using Puppet through the foreman, but whatever way the parameters are being transferred from the foreman to the agent should be visible to this invocation. David has a comment.
You can, if you have an ENC configured, it's usually a script that's run by the master to look at, and you can just run that script and pass the FQDN as parameters to see what's returned from the ENC. Yes. No.
Oh, I think, sorry to interrupt, I believe we're talking about two different concepts here, because the ENC will usually pass some values that are being used to compile the catalog for each individual agent, but these configuration values here, those don't really have anything to do with node-specific values that you pass through your ENC or through your manifest, where you can set node variables. I mean, these are really, let's just see it. So, yeah, that's a great example. But all the things that you can pass on the command line, right? Like the wait for cert option, or the state file, or all the information that the agent needs to do its operation and to save its stuff, to know where to send its reports, etc., etc. I hope this somehow clears this up a little, but otherwise, let's talk later. Other questions? Okay, let's move right on to the next issue. Focus. There we go. So, assuming you have everything configured okay and you start working, but then Puppet just falls on its face, which it does. And I've looked up some of the most exciting error messages, and these are my favorites, where Puppet will tell you, hey, I cannot invoke a method on nil class. I mean, I don't know, if you're lucky you've never seen this, but if you do, it's never fun. Because this is basically the Ruby equivalent of the null pointer exception, which, if you're not really deep in the code base, just won't tell you much. So it will you can glean an idea of what's going on if you look at the stack trace of where the error actually happened, and for that you need to just pass the -- trace option to your Puppet invocation. And I just remembered that I think I forgot to. Let's see if I handled that. It's extra fun when you have a German keyboard but use US layout. So great. Okay, so that's pretty normal. Nothing to see here. You know what? Let's just head back to the canned things. So, what I've prepared in advance is a case where you run your agent and you get a cryptic error, and in this case it's not even so bad because you get a manifest location. Oops, focus. Like in this instance, you would of course look at the manifest at that point to see what the compiler was trying to do here. But let's just assume that this is a very innocuous piece of code, and you don't know why it's failing this way. And sorry. And yeah, what you want to do is see why are you doing this. So let's look at traces. So if you just add the trace option, then you're met with the same error message that I truncated here. So here, just imagine that the whole shebang appeared, and then there's stack trace. And this one actually cannot really tell you much. So what it's saying is, yeah, I was doing a REST call, and I was looking at whether I was getting a 200 OK response. And the context was I was trying to get my catalog. So yeah, thanks, Captain Obvious. I know that I was trying to get a catalog, and that didn't work. So what you want to keep in mind is that this is happening on the master, so you have to trace the master. You cannot get away with tracing on the agent. So another helpful thing that you can do on your master rather than the agent is if you got a shell on the master, you can log into there and just compile the catalog for one specific node that you specify. So in my preparations, the FQDN of my node was fflaptop.local. Added with the -- compile option, and of course I requested a trace. And what Puppet will tell you is, okay, I'm compiling. And then the cryptic error message, that is not so cryptic, but the trace this time is rather telling, because you see, there was some parsing going on. If you're familiar with the whole Ruby deal, then you can even guess that as psych is involved, that this was probably some sort of YAML problem. But otherwise, the fact that this happened in the YAML backend of Hira, when it did some lookup operation, this could indicate to you that, oh yeah, there's some YAML that is malformed in some kind of way, and now you can go ahead and hunt the actual error. So that's one example where the trace can be actually helpful to you. Now, in the real world, so this is a trace that I took from an issue that we had with one of the modules that I worked with, and there was something fishy going on. I think it was a Puppet bug concerning the class containment code, whatever, and this is pretty opaque. So all this is telling you, okay, the compiler class had been in the process of compiling something, and it called a method that is named toResource, and that in turn tried to convert something to a catalog, perhaps, but it really is nondescript as well. What you could do is jump into the code right here, into the code place to try and get a feeling for what's being done, and perhaps guess what value isn't there that it's being expected. But yeah, this is a level of debugging that you usually don't want to descend into. So the most useful part of this trace is that you can attach it to the bug report that you can file with Puppet. That's pretty much it. Okay, enough with the tracing. Any questions, or can we just move along? Let's move along. Okay, so assuming, yes, you have everything configured right, and there's no weird error messages, but as I described earlier, so you've built something cool, you have exported resources, say, and you are expecting your LS node to tell the backup server how to configure its backup, and on the backup node you import all the jobs, and it just won't. And this isn't even limited to exported resources constructs. This can happen with all forms of manifests, like the simplest of manifests that should just put a file or start a service on your node, and it won't. And that's yeah. If I encounter this, it's pretty demotivational. And of course, the first thing you usually do is you enable debug mode, like call Puppet agent with --debug, and you get this wall of text that may tell you about, okay, I'm looking at the resource, but I'm for whatever reason I think I don't have to do any work on it. In other cases, you just don't find anything, and it's inconclusive. So what I will do in this situation is I'll really grab the catalog that the master has generated from the manifest and send to the agent and inspect that. Okay. We can try and do this live. Okay, let's see what this agent here does. You're kidding me. Yes, you are. The hell? Okay, that literally worked like half an hour ago. Okay, debugging. Right. Exactly. Yeah. That's exactly it. So, that's tiny. Oops. Forget the master. How can I forget the master? Another neat debugging tool, just launch a standalone master somewhere. You can do this on your local box. I do this on my local box all the time. Bam. And yay, this is still possible. Somehow doing this is deprecated. I really hope that it just stays deprecated and isn't removed. But yeah, I'm barking up the wrong tree, I know. So now we got a master running on the local host. Remember how this is weird that the certificate is signed for localhost, but this is outright necessary because, yay, local networks. And now the master's up, and the agent runs, and it doesn't do much. What it's doing is it writes a nice message to the terminal. So the easiest way to look at the catalog that is responsible for this action is yet another subcommand that is not used often, and that's the Puppet Catalogue subcommand. And you have to tell it what the action is. In this case, it's just find. Let's do it. So, let's just scroll. Okay, here's where it starts, right? And what you get is a nicely formatted JSON that is the information that is passed from the master to the agent. With some boilerplate information like UUID and the environment that can be interesting in debugging. And then there's the resources. Again, there's some boilerplate stuff in here, like stage main. I mean, really, who cares? And class settings. They can be confusing. This is just something that Puppet uses internally that you don't really define yourself anywhere. But if you keep looking, you eventually find the one resource that we actually added to the manifest and that ends up in the catalog. So this is, if you're wondering why your notify doesn't show up and are not sure whether it's actually in the catalog, you can use this to just take a look and see if the things are there. And this is pretty boring because there's not much going on in this resource, but let's look at a more complex example. And yeah, what I'm doing is I have prepared a node in my site manifest that has a little more going on. I think it's this. And you know what? Guess that's safer. Because compiling. All right, so again, lots of JSON. And here we actually encounter some resources. So this is a defined type I'm using. Not that much to see. So I'm creating lots of users. So let's see if we find some user type resources. And there's one, right? So here's a user resource that is actually from the manifest. Or you know what? Let's look at the manifest. Or should I? I mean, yeah, why not? Because literally, I keep forgetting how this is set up. Oops. C config print can be helpful for forgetful people as well. Okay, so what I wanted to do was build a simple manifest that adds lots of resources to my catalog, so I have something to show. And I built some defined types to make this easier. And what this does is I can just pass a username, and it will create a user by the name. It will create the home directory and a couple of dot files in this home directory. Also an authorized key for good measure. So I've just built a list of names, and I limited this. It used to be 50, but that led to pretty serious compilation times on my machine. So we just use around 20 or so, and then just declare these. Okay, so here's one of these users, and in this view we can very easily check how did it end up looking in the catalog. Like, okay, it's ensure present, this is his home. This can be really helpful if your manifest does some, let's say, evil tricks like overriding parameter values. That can be pretty difficult to debug if your overrides are all over the place. And this is the truth. Like here you see what's getting sent to the agent, and that could very well explain why the agent is not doing what you expect looking at your manifest. Same with the files, right? And here are all the parameters that keep floating in. So this is neat and all, and you get a comprehensive view, but it's to be quite honest, it's only half the truth, because this is what's internally referred to as the resource catalog, and if you want to look even deeper at what's going on inside the Puppet process, you have to throw some Ruby at it. And the way to do this is Puppet will always cache the catalog it received before applying it. So let's look at the whoops. Always forget the all the configs. So there's lots of caching going on, and what's most important is the right here is the where do we have it? The catalog cache terminus. Easy to remember, right? And it's either JSON or YAML. and the default is JSON. So Puppet will put a JSON file somewhere that has just this catalog information. So I keep forgetting that as well. I think it's here. So that the JSON terminus puts things in the client data dir. Whereas if you choose YAML, it uses client YAML dir, which has no underscore, and everything is really confusing. I suppose it's history. So let's see if we have a cached catalog, and we do, right? There's the one. Where's the mouse? There it is. The one with just the notify, and then there's our complex catalog we just looked at, and oops. So, JSON, right? Some great things about JSON. It's pretty compact, it's very portable, and it's very readable. Yeah, that was a joke. So, of course, you can load this into any, what have you, Python, Ruby script, whatever your poison is. I prefer Ruby, but let's do the whole shebang and actually request a YAML catalog, because that allows some even neater tricks. And that is not what we can use. We have to do this. By the way, if you run with --no-op, then recent version of Puppet will not write a cache catalog. That's just for security. It would be awkward if you do a no-op against your crazy experimental environment, and that gets cached, and then for some reason the next run uses the cached catalog because something fails on the master and you have your weird experimental stuff applied. That will be bad, so there's no caching going on, which means we cannot do a no-op, we have to do an actual run, which is fun with this manifest because it tries to create users and stuff, but I'm running without root, so expecting some red on the console right now. Compiling. Got some thoughts. All right. Some red, some yellow, but that's not the important part. We wanted to look at the cached catalog, and as I said, it's now in the client YAML directory, and here we go. So this is somewhat more readable, but what's really important is that this YAML is annotated, so that Ruby can actually load it and bless it into an actual object and not just this hash structure. So let's do this. Do I even... Oops. Oh, there it is. Okay. Let's start with IRB. So, how much time do I have left? Cool. So IRB is your interactive Ruby shell, and you can run your Ruby code here. And what we want Ruby to do now is load that YAML that we just looked at, and give us an object that we can inspect. So for one, you want to load the YAML module, and this is pretty cool. You can just load Puppet as a library, and now all the things that Puppet can do, we can do from our interactive shell. So let's try and say, let's call it cat. So let's make a local variable named cat, and we want to load some YAML from a file, and it's this one. See if this works. It did. So we have a catalog, and this is nice and all, and you can do things like pretty print the catalog, which is not really helpful because it's just a huge wall of text. Right. Or we can say inspect the catalog, which is mildly more helpful, but not really. So what we really want is yet another piece from the Ruby toolbox, which is the pry debugger. And pry is another gem that you can install next to Puppet and everything. And let's load it. And let's enter it. So this is kind of a mantra. Require pry, binding.pry. This is pretty much what I do whenever I face any Ruby troubles. I can also put this right into some Ruby code file where something goes bleak, and it's essentially a breakpoint and puts me into this debugger. So and what this does for me is, for one, let's see what happens if I just, yeah, this did not work. Oh, do we even retain our catalog? We do. Okay, so pry allows some interesting stuff. Like I can cd into this variable that I have created earlier. So I've done a cd cat, and cat is the variable name, and now I'm in the catalog, if you will. And I can use ls to see what's going on. What are the local, what are the methods that I can use here that have been defined for such a catalog, and what are the local member values, right? So I can now, I can now just look at, say, the version of this, or the, what have we, environment. So, this is the resources. That's a pretty big list of resources, and it's a huge array, and somehow I expected this to be more insightful. There, that's better. Okay, so the add resources, the member variable, just holds a list of these key values, and if instead we invoke a method, self.resources, then we get actual information. But still, again, that's not a huge improvement over what we had earlier in the JSON. But the good part is that we are now in this Ruby world, and we can start looking into things. So let's make another variable, res list, and again we can cd into there, and this is just an array, but I like doing this because I always forget how the filtering and selection methods of Ruby arrays work. And here I just got them on hand, and I can do cool things like give me the description. Sorry. Description of methods like find all and filter and what have you. So this is really the most comfortable way to navigate my Ruby resources and to look at things and to get help along the way. So if you're in doubt about what Puppet is doing, consider using lots of pry. Okay. Here, even the slide says so. Okay, we're almost done. So, of course, you don't want to get debugging anytime you encounter some issue with Puppet, so it's a much better idea to get some help. A good place for that is Puppet's own Ask site. Man. Which is basically Stack Overflow, but just for Puppet. It's cool. Then there's the Puppet Forge, of course. Many things in Puppet you don't even have to solve yourself. There are modules for a wide range of applications, and if all that else fails, you can at least look at other people's code, perhaps get some inspiration. The mailing list is pretty good. That's a Google group. There's IRC, there's a Slack now, that's pretty new. There's the Pugs, the Puppet user groups. Hi, Martin. And yeah, you're not alone. Reach out, get help. Puppet community is there for you. So thanks for listening. Before we go to the final Q&A, some final notes. Yeah, we too are hiring. As I said, there's managed services, there's lots of operation roles, but not only those. There's also a data science department. We can outfit our customers with custom big data solutions. And yeah, if you know anyone who's looking for a role in this kind of alternative tech sector, yeah, just reach out. Talk to me or check out our careers page. There's lots of cool roles. Yeah, I think it's pretty nice deal. Check it out. There's a couple books that you can read. I personally vouch for their quality. I think Martin over there will also vouch for them. And finally, there's another tool that I'd like to, yeah, inform you about. It's an early stage of development, but it's pretty neat. It takes some ideas from Puppet, but expands on them and has some pretty fresh designs. And yeah, it's called MGMT. It's written by James, and all the info is on the technical blog of James. And yeah, if you want to see some fresh new innovative ideas on configuration management, you might want to look at MGMT as well. And that's it. More questions? Yeah, that pry was really not a good idea to give you right after lunch, right? That's a lot of stomach.
So do we have any questions here now? Anyone?
But yeah, thanks for watching me ramble on about Ruby and all the internals.
Thank you very much, Felix, for being here.
Bye.